Hey everyone, welcome to our second installment of oscilloscopes. If you remember what we did last week, we looked at the basics that every beginner needs to know about oscilloscopes. In this installment, what we're going to do is we're actually going to look at additional information that beginners need to know. Not quite the basics, but additional information beginners need to know. And this information actually has to do with being able to read signals external from the oscilloscope, in addition to looking at multiple signals coming into the oscilloscope. We'll also have a little bit of a review of what we did last week before we get into all of that. And we're going to do that right after this break. Do you remember the basics? Test your memory by using this oscilloscope. Do you remember the basics? See if you can determine how many channels we have on this oscilloscope. If you said 2, you're correct. One channel here and one channel here. Each channel has its own voltage per division knob, and those are here for channel 1, channel 2, and each channel has its own position knob. This is channel 1's position knob. This is channel 2's position knob. Each channel has a port where you enter the signal. This is channel 1's port. This is channel 2's port. We also have a time per division section and a time per division knob shown in this section. And we also have a position knob which will show us or move our signal horizontally. The fourth area that you should remember from last week is this area where we will be able to obtain our predetermined signal. In the case of this oscilloscope, our predetermined signal is actually gathered from this area right here where it shows calib or calib. And what we see here is that this signal should have a 1 volt peak-to-peak output voltage. Good job. When working with an oscilloscope, it is important to know what your limits are, especially when you are looking at signals that are generated from outside of the oscilloscope. So let's take a look at how you can figure out what your limits are. Your typical oscilloscope on the front typically tells you 2 sets of important pieces of information. First, if you look up on my oscilloscope, you'll notice that it says that this oscilloscope has 2 channels and also that it is a 60 megahertz scope. What that simply means is that the oscilloscope allows for me to put 2 signals into the oscilloscope, into channel 1 and channel 2, and then also the maximum frequency any of those signals can have is 60 megahertz. When working with an oscilloscope, it is important to have good oscilloscope probes. For this video, I will use 2 oscilloscope probes, and here are my 2 oscilloscope probes that I will be using. On your typical oscilloscope probe, there will be a switch that allows you to switch from X1 or to an X10 setting. We will explain what this means a little bit later. This is my second oscilloscope probe, and on here you'll notice that this one actually has 3 settings: X1, X10, and a ref setting or reference setting. Again, we will explain what all this means a little bit later. So what should you do if the voltage that's displayed on your oscilloscope when you're looking at a signal doesn't make any sense? We'll use this example, the following example here, to demonstrate what you should do. If, of course, you're trying to stay away from these buttons over here on your oscilloscope, these extra buttons. In our example, what we're going to do is we're going to look at a signal coming in on channel 2. For my oscilloscope, in order to go to channel 2, I'm going to need to hold down this button for a few seconds so that channel 2 signal can show up on the screen. This is what it looks like initially when I hit that button and there's no signal going into channel 2. Remember that we will have our ground line shown on the screen. In this case, my ground line is halfway between the top and the bottom of the screen where I like to have it. And you'll notice here also it says that I'm looking at channel 2. Alright, for channel 2, what you're going to do now is you're going to insert, or actually I'm going to go ahead and insert a signal into channel 2, and the signal that I'm going to use is I'm going to use the reference signal that's coming out of the oscilloscope. So in order to do that, I'm going to take my scope probe, I'm going to connect it to channel 2, and then I'm going to connect the other end, the end with the grabber on it, to the reference signal that's produced from the oscilloscope. Alright, so when I do that, here's what I get, a signal on the screen that looks sort of like this. What you'll notice is this is our signal here, this is our reference, it goes up, and it looks like part of the signal is actually off the screen. However, though, for the part of the signal that's on the screen, that part covers, let's see how many volts per division. So we have 1 division here, 2 divisions, 3 divisions, 4 total divisions. And we also know that each division is represented by 2 volts, as shown here. So if this is the case, then my voltage peak to peak, just based on what I can see on the screen, is indicating that because I have 4 divisions and it's 2 volts per division, then this is 8 volts. But remember, coming from the reference, I should only be getting 5 volts. So in order to further explore what's going on here, we're going to adjust the signal, bring it down, so that we can see the entire signal on the screen and get a good feel for exactly what's being shown. So what I did was I adjusted the position knob for channel 2 so I can bring it down. And so here's where my signal is once I've done that. So you'll notice that reference is here at the bottom. And now what you can see is from bottom to top, from peak to peak, I have 1 division, 2 divisions, 3 divisions, 4 divisions, a total of 5 divisions. And now, in this case, I've adjusted it both in voltage and position, because in order to get the entire signal on there, I had to move the voltage also. You'll notice that my voltage per division is actually 10 volts. So what this means then is if I have 1 division, 2 divisions, 3 divisions, 4 divisions, 5 divisions, that means then that this signal from peak to peak, 5 divisions, 10 voltage per division means that I'm looking at a 50 volt signal. But remember, again, the signal that's coming in on channel 2, because I'm looking at the reference, is only 5 volts. So from peak to peak. So what that means then is that somewhere in my oscilloscope there is a problem. So let's do a little bit of math to understand what's going on. So if I form a ratio between my voltage that I should see, which is 5 volts peak to peak, versus what is actually shown on the screen, which is 50 volts peak to peak, you'll notice that there is a 1 to 10 or 1/10 ratio that's formed there. And so when I analyze this, remember we're using a 1x probe, so that kind of tells me some information. What it means then is that the signal that's coming in has been multiplied by a factor of 10. And the reason that's been done is because of right here. You'll notice that it says that the oscilloscope is expecting a probe, a 10x probe or x10 probe, to be connected to the oscilloscope on channel 2. So because this is the case, then what it means is that the signal that is shown on the screen was actually readjusted by the oscilloscope, assuming that the signal that was being measured was actually divided by 10. So what it did was it went and tried to correct that by multiplying the signal internally by 10 and showing it on the screen. So in order for me now to be able to go ahead and display the correct information on there without, again, touching those buttons along the side, those soft buttons or any of the extra buttons there, is to just switch my probe from 1x to 10x. And once I've done that, you'll see that my new signal, once I've done that, now makes more sense. I've changed the voltage and I've changed the position of that signal. And so according to this, I have a 2 volt per division signal division shown on the screen here. And so if I look at the amount of divisions from my peak to my peak of this signal here, we have 1 division, 2 divisions, 2.5 divisions at 2 volts per division here. And so 2.5 divisions times 2 volts per division gives me the 5 volts peak to peak that I'm expecting. So again, when you're looking at a signal and it doesn't make any sense in terms of what you should be getting, and a good way to check to see what you should be getting, of course, is to start with the reference. What you need to do is then look at what caused that. In my case, it's because channel 2 is set at a probe of 10x voltage. This is what caused the issue. So one way to go ahead and correct that issue without having to use the buttons again, because again, if you're a beginner, a lot of these buttons can be real intimidating. What you can do is just simply switch the switch on the probe, and that will rectify this issue. All right, it's time to read signals from multiple channels on our oscilloscope. As you may have guessed already, since my oscilloscope only has one reference signal, or the ability to generate only one reference signal, I need to get a second signal from somewhere else. So we're going to have to use a second device in order to generate a second signal for one of my channels. In order to look at both signals, multiple signals, and again, since I have a 2-channel scope, in order to look at both signals on my oscilloscope, I'm going to need to press both the channel 1 menu key or button and channel 2 menu button in order to see both signals. And I'm going to need to hold both of those down for a little while. On your oscilloscope, you may have to do something else different. So look at your oscilloscope. You might be able to figure out what it is relatively quickly. Now, when I push both buttons down and no signals are going into channel 1 and channel 2, again, that's no signal going into channel 1 and no signal going into channel 2, what I end up looking or seeing on my screen is I end up seeing 2 ground signals on my screen in approximately the middle. And that was kind of set up initially by me so I can see both of those in the middle. And if you look here to the left side, you'll see that a 2, or it's kind of hard to see that a 2 is actually overlaying or laying over V1, and that indicates that both of my signals are here in the center of my screen. When that occurs, it's going to be a little bit hard to see both signals on the screen at the same time. So what I'm going to do is I'm actually going to adjust it so that one signal is above and the other signal is below. And what you'll see here is when I do that, so I move the position button or roll the position knob for 1 so that signal 1 goes up, and I move the position knob so that channel 2 signal goes to the bottom. And so again, what you'll see here is you'll see that signal 1 is at the top, its reference or ground line is at the top, and signal 2, its ground line is at the bottom. Now, I need to import a second signal as I indicated into the oscilloscope. So what I'm going to do is I'm going to use my function generator to generate a 1 kilohertz signal with a frequency, or pardon me, a 1 kilohertz signal which has a frequency of 1 kilohertz, and it has an amplitude of 5 volts peak to peak. There's no offset. And so Once I set that up, and by the way, this is going to be a sine wave that I'm going to put into my oscilloscope. When that happens, okay, once I've got that set up, what I need to do then is I need to connect both the probes, one going from, in this case, channel 1, is going to be connected to my function generator that's producing my sine wave, and channel 2 is actually going to be connected to the reference, which again is that signal that's coming from within the oscilloscope. When I do that, on my screen I get my two signals, channel 1 being my sine wave that's generated from my function generator, and channel 2, which is the reference, being generated by my oscilloscope. Channel 2, which is being generated by the oscilloscope, remember, is a square wave, and my channel 1 is a sine wave. What you'll also notice here on the screen is not only do I have the volts per division for channel 1, but I also have the volts per division for channel 2. Okay? What you'll notice here also is that I have the volts per division for channel 1 and the volts per division for channel 2 both on the screen. And so if you look here, you'll see channel 1's volts per division is 2 volts per division. And you'll notice here that channel 2's volts per division is 2 volts per division. And so if we count through here, you'll notice that there's 1 division, 2 division, 2.5. So that means that's 5 volts peak to peak. And up here, that's half, that's 1.5, that's 2.5. That's now going to be, or pardon me, that's a quarter. That's 1 1/4, 2 1/4, and that's another quarter, making it 2.5. So this signal also is 5 volts peak to peak. And if you remember correctly, my frequency was set at 500, or pardon me, 1 kilohertz for that second signal, and so, or for channel 1 signal. And so what that means then is that for every cycle I get here, I should get a cycle up here. And you'll notice that that all matches up. All right, so what if we wanted to change that signal coming in on channel 1 now to actually something different? We want to change it to, let's say, 2 kilohertz. Okay, so the frequency of channel 1 is going to be changed to 2 kilohertz. We're keeping the amplitude at the same, 5 volts per division. What we end up with then is what's shown on the screen here. Again, we're still using 2 volts per division for both channels. And you'll notice that for every cycle, so if I start from here, go over here, and get back to that same point, for every cycle here, I end up having 2 cycles of sine wave within that one cycle here. And so that shows then that my frequency for the sine wave, it's twice as frequent, or a cycle comes around twice as frequent as for channel 2. And so we've successfully shown that we can input 2 signals into our oscilloscope in channel 1 and channel 2. We can display both of those signals on the screen at the same time, and we also know how to analyze them. And how to analyze them, we have a separate volts per division for each channel. However, though, the frequency, so our seconds per division or time per division scale here is the same for both. And so we can see that on our screen. And so we have successfully done this, and so we have learned a lot about using our oscilloscope. Well done. All right, so next week we'll look forward to doing a few extra stuff with the oscilloscope. We're going to start talking about some of those soft buttons so that now we can advance our skills when it comes to using our oscilloscope. In the meantime, of course, please do practice how to use these same functions and so forth that you've learned in this video on your own oscilloscope. All right, I'll see you next week. information, blah, blah, blah. The basics. External. Which one?